Welcome to the Math Record. Today I'll be covering the ICTM Regional 2016 Division AA Geometry, which I'll be covering questions 8, 11, and 12, and then I'm going to be covering questions 14, 15, and 20 in the next part. Okay, as usual, scroll down on 20. Okay, so now let's begin with number 8. AB, FC, and DE are parallel to each other. AB is 11 and FC is 3. Determine the length of DE. So let's kind of draw this figure. So we have something like this. Then we have a bigger one. Then let's connect these two. Connect from the top to the bottom, the top to the bottom, then from here. So we know that this length is 11 and this length is 3. So basically you could solve this by using similar triangles. So let's call this X, call this A, call this B. So this is 11 over A plus B, right? This big triangle to this small triangle. So 11 over A plus B equals 3 to B. And then 11 cross multiplying 11B is equal to 3a plus 3b. So that gives us the 8b is equal to 3a. Okay, so we know that. Now we can use this big triangle and then this small triangle will give us x over a plus b equals 3 over a. So we know that x is going to be equal to 3 over a times a plus b. So to cancel our a, we need to make a in terms of b. So this would be the same thing as x equals 3 over a times our a plus, and our b is equal to 3a over 8. So then this a and this a as to basically you could just distribute out and cancel out this one. So that would just give us 3 times our coefficient here is 1 and then 8 or 8. So that is 11 over 8 times a 3 would give us 33 over 8. And that's our answer for number 8. Basically just use similar triangles. Okay, number 11. Two intersecting spheres have diameter 30 and 40, and the center of the spheres are 25 units apart. The area of the circle formed by the intersection of the spheres has a numerical area of k pi. Determine the exact value of k. So let's draw a picture. So imagine we're looking straight at it. So instead of looking at a sphere, it kind of looks like a circle. So we have a circle of diameter 30. Actually, let's make this a bit smaller. And then we have a diameter of 40. Okay, so let's say something like that. I don't know. Okay, so center of circle, center of circle. So, oh, sorry. Let's line this up actually. It'll look a lot better. Yeah, that's fine. So we know that the distance between the center of circles are 25. We know that the diameter is 30 for this one. So if diameter is 30, that means this length over here is 15. So since the distance between the center is 25, let's actually make a straighter line. And right, we know this diameter is 15. That means, and the distance is 25, then this is 10. And we know this diameter is 40, so divide by 2 gave us a radius of 20. So for 25 minus 20 is 5 on this side. So we know the entire distance is 25, so 25 minus 5 minus 10, that is equal to 10. Okay, so how do we get our circle? Well, basically, let's just actually write 10 right here. This entire length is 10. I just moved it over so I could draw something. So we're going to draw our height. And remember, this is supposed to be a circle, so it's kind of like 3D. It's kind of hard to like draw the entire 3D circle. But basically, when you kind of look about it, like let's say you're facing here, and you're looking this way, right? While we're looking at this way, it kind of looks like it's just a line. But if we're looking this way, a circle, I mean a sphere and a sphere intersecting, this is gonna be our basically the diameter of a circle, and then we're basically going straight around like in a z-axis. So it's kind of hard to draw in 3D, but like basically it's like that. And this one is going inwards while this one's going towards you. So then we have some kind of circle. So basically this tells us that this is our center, and then this height is also our radius of our circle. So we just need to find the height. So all we had to do is basically just do some Pythagorean theorems. So we know this radius of 15, this is a radius of 20. So then we have 5 squared plus, and we could call this x. So this is 10 minus x. So that's x squared. So I mean 5 plus x squared, sorry about that. This is just that length plus our height squared, which is also our radius, is equal to 15 squared, which is 225. And then 10 plus 10 minus x, which is 20 minus x squared plus h squared is equal to 20 squared, which is 400. And now we could just do some math to get our h. So we have 25 plus 10x plus x squared plus h squared is equal to 225. And then we have 400 minus 40x plus x squared plus h squared equals 400. And then I'm going to cancel out these 400s because they're basically the same. Cancel out the 25 here and this 225 to make 200. So then we could subtract the first equation by the second. So 10 minus a negative 40 is a 50x. And then the x squared and h squared cancel each other out. So 200 minus 0 is also 200. So that means x is equal to 4. Now we could plug it back in into one of these equations. Let's use this one to get our answer for h. So 5 plus 4 is 9. So 9 squared is 81. So 81 plus h squared is equal to 225. So h squared is equal to 164. Uh, wait, sorry. 144, I mean. So our answer is pi radius squared. So then our radius is going to be 12, but also it doesn't really matter because h squared equals r squared. So that gives us that our answer for k, which is r squared, which is also h squared, is 144. And that's basically it for number 11. Okay, now number 12. In the diagram, ACB is a right angle, which is 90 degrees. AD is 5 and DC is 10. CB is equal to 20 and EB is equal to 17. Determine the area of ADE. Okay, so draw a diagram. And then we have some kind of area like this. And we know AD is 5. We know DC is 10. And we know CB is 20. And we know EB is 17. So we need to find this length first. So basically, I know this is a right triangle, so that basically means we gotta use the Pythagorean theorem. So 5 plus 10 is 15, and this is 20. And you could do the Pythagorean theorem if you want, but you could just think about your Pythagorean triples. So 15 divided by 5 is 3. 20 divided by 5 is 4. So this is going to be a 3, 4, 5 triangle. So then since you need to scale by 5, 5 times 5 is 25. So this entire length is 25. So 25 minus 15, that gives us this length is 8. And that's basically it. So how do we get the area of this triangle? Well, an area of a triangle is always basically, let's say we have a triangle and we have side length A, B, and this angle, let's call theta. It's just A times B times sine of theta divided by 2. That's the area. So basically, we have 5 times 8 times sine of this angle. What's the sine of this angle? Well, it's just 20 over 25. And then we divide by 2, or you basically just multiply it by 1/2. So then 5 and 5 from here, that makes a 4, cancel out with this 25, and then this 4 cancel with this 2 makes a 2, so 8 times 2, 16. And that is your answer for number 12. And that's basically it for the first part. And here are all the answers. Well, thanks for watching, and I'll see you at the next part of the math record.